The oscilloscope is a window into our electronic world. But sometimes that window isn't as clear or as bright as we would wish. If electronic errors happen only occasionally, amidst millions of quite normal events, or if high-speed events happen only once, or very infrequently, we may never see them. A normal oscilloscope may be inadequate to the task of revealing them. The screen appears blank. There is a signal triggering the scope. Note the front panel trigger indicator. It flashes when a trigger occurs. Sometimes, with a great deal of effort, we can record an event on a normal scope, if you know it is there. We can use a high writing speed scope with P11 phosphor, a fast camera, high sensitivity film, and perhaps pre-fogging techniques to achieve the very highest writing speed, if we know the event is there. But sometimes, our best efforts fail. Now let's look at those examples on an oscilloscope with writing rate adequate to reveal everything. This is the 2467. We call it Bright Eye. On this scope, the occasional error events are now clearly visible. This is a metastable flip-flop. Occasionally, it returns to a logic high rather than switching low. This can happen when a clock edge is close to the data edge. On a normal scope, these events are quite invisible against the bright background of normal events. They occurred too infrequently to excite the CRT phosphor. And here's the second case. A narrow, fast-rise pulse with a low repetition rate that was invisible on the normal high-speed oscilloscope. Note the sweep speed. Why does this instrument display those pulses when other scopes won't? As the scanning beam in a normal oscilloscope goes faster and faster, there are less and less electrons per sweep to excite the phosphor. At very high sweep speeds, there are too few to make the phosphor glow visibly with a single sweep. If there are several thousand sweeps per second, they supply enough electrons. It's the number of electrons per second that makes the phosphor glow. So, why not supply more electrons in each sweep? There are trade-offs between beam size, current, high voltage, deflection characteristics, and other factors that limit the number and power of the electrons we can supply in the scanning beam. In a high-speed scope, these factors are already optimized for trace brightness. But there is another way to supply more electrons. The 2467 CRT supplies more electrons with an electron multiplier just behind the phosphor. This type of electron multiplier is called a microchannel plate. The plate is a glass honeycomb structure of very small glass tubing fused together. Coatings are applied to this assembly, and inside the CRT, it's supplied with voltage. Each tube is an electron multiplier. When a single electron from the scanning beam enters a tube, it causes several thousand electrons to leave. This process is self-limiting in that only so many electrons can be drawn from each tube per second. But this number is very great, and the limiting or saturation tends to even out the light from the waveforms. One trace is easily visible, but 1,000,000 traces are only 100 times brighter, not 1,000,000 times brighter. This saturation effect helps us see single sweep events, even in the midst of millions of similar events. Now you can be far more certain that error events are really not happening, rather than happening at a rate you can't see. Now you're asking, how do I operate this wonderful new scope? The same way you operate other 2400 series scopes. It has 350 megahertz bandwidth and 1 nanosecond rise time at the probe tip. The scope monitors itself. Channel plate CRTs can deliver so many electrons to the phosphor that they can shorten their own lives. The 2467 automatically monitors this current and drops the intensity a few tens of seconds after the last front panel control change. A few minutes later, it automatically shuts down the intensity altogether, then flashes a shutdown message periodically to remind you it's still on. To restore the intensity, just move any front panel control. All this conserves CRT life. The scope also automatically moves the readout characters around to new phosphor areas each time a control is changed to avoid aging those spots. There are some new functions in the 2467. One is a 50% trigger level selector button. This function auto-level triggers a waveform at 50% amplitude, as if the trigger level control were centered and an auto-level sequence was initiated. It just does it faster. Another function available on the 2467 is cursor measurements on a delayed sweep display. Now, voltage and time cursor measurements can be accurately and swiftly made on delayed sweep waveforms. Next to the CRT, there are 3 new buttons and some new labels for 8 other buttons. These are the controls for a very powerful new set of capabilities. The first is Auto Setup. This automatically selects the right vertical, time base, and trigger settings for a usable display on a waveform. For regular, repetitive waveforms, even narrow pulses of low-duty cycle, the scope will present the waveform at 2 to 4 divisions amplitude and 2 to 4 divisions horizontal width. The scope will even adjust the position controls to place the waveform on the screen. It's not a genius. If the signal is noisy or in an irregular pattern, it can't know what you want to see. But for most waveforms, it will present a display that will get you started. And for more difficult waveforms, this scope has another remarkable feature. When you've made the measurement once, with these buttons, you can store the front panel settings for that measurement. You can even label each setup with a short message. That's done with the delta knobs. 8 front panel settings can be stored and recalled in any order with these 8 buttons. 12 more front panel setups can be stored and recalled using the delta controls. All control settings are stored and recalled from battery-backed non-volatile memory. These setups can be grouped in sequences, each sequence with a beginning and an end. Each can be a mini test routine, the steps in the routine done in rotation. The labels for each step can be a word, a test point number, the measurement result, or whatever 8 characters are appropriate. All this means that you can solve a measurement problem once, then pass that solution on to others, or store it for the future. If the instrument has the GPIB interface, the stored setups can be transferred directly to another instrument, or to a controller, then archived, made part of longer measurement procedures, or whatever your imagination dictates. The stored setups can make an instrument a mini-system, or a detachable component of a larger measurement system. If your interest is in systems, EasyTech 2400 software, a test program generator, is available for developing applications programs for 2400 series scopes and the Tech 4041 controller. Tech Guru software is available for the IBM PC and compatibles. The 2467 has a vast amount of measurement power. The writing speed adapts to the measurement conditions, revealing waveforms that are invisible on ordinary oscilloscopes. Single-button auto setup brings a whole new level of meaning to the words easy to use. Setup, save, and recall and front panel setting sequences make any scope user an expert and speeds up an expert's results. This scope reveals all, fast. Bright Eye is the fastest portable scope in the world, the fastest writing speed, the fastest to set up and use. It will reveal problem waveform details not visible on any other portable scope. If you need basic information on operation and features for this or other 2400 series oscilloscopes, watch the videotape 2400 series operation. For demonstrations, ordering information, and application seminars on these products, contact your local Tektronix sales engineer.